Now we will discuss in detail about establishing cause and effect relationship. How cause and effect relationship is established. How we establish this relationship. These types of studies, these types of researches are applicable to each and every stream. In biomedical researches, in management studies, in business studies, in social science researches, in humanities researches, in educational researches, in physical education researches, in each and every subject, we can establish cause and effect relationship. Let's start our story. I divided this presentation into different parts. We will cover only 5 parts. We will start from a prologue, we will start from a base. Then in the second part, I will discuss about how to establish cause and effect relationship. In the third part, we should have an idea about the variables and their types. Fourth part will be use of appropriate. This is the most important part. The use of appropriate design and use of appropriate statistical tool to establish cause and effect relationship. And we will not discuss about testing assumptions. And let's start with the first, that is prologue. Let's start with an example. Please try to understand this hypothetical example. An article was published in the newspaper. You will be agree with my statement. The newspaper also publishes the article on the basis of researches. The article was based on a research study, and there was a comment in that article. The heading of that article was, "Those who take curd daily are intelligent." Those who take curd daily are intelligent. It means from this statement, we can say that if any individual want to become intelligent, take curd regularly. Is it okay? Is it truth? No. We should discuss about this. It means several questions may arise in mind. We all are from academic pursuits and we are curious by nature. So several questions may arise in our mind. The question may be, is there any cause and effect relationship between curd and intelligence? Is there any cause and effect relationship? Second question may be, hypothetical question may be, those who take curd regularly, are they brilliant? Third question may be, those who want to become intelligent, should they take curd regularly? Ladies and gentlemen, here the heading of the newspaper article is, those who take curd daily are intelligent. This may be possible that who are already intelligent, they regularly take curd daily. Possibility of this also is there. It means we have to, without establishing the cause and effect relationship between curd and intelligence, we cannot say that those who take curd daily are intelligent, or eating curd or taking curd leads to improvement in intelligence. So how to develop cause and effect relationship? We have to develop this cause and effect relationship between variables. It means no experiment was conducted by that particular newspaper before publishing that article. The article was on the basis of an observational study. That article compared two groups consisting of those who take curd and those who do not take curd, and compared, and those who are taking curd were more intelligent, and that was compared by using which technique? Independent t-test. Since there were two independent groups, those who take curd and those who, but on the basis of this comparison, we cannot say that there is a cause and effect relationship between curd and intelligence. It means this was concluded on the basis of a relationship. Ladies and gentlemen, on the basis of relationship studies, we cannot establish the cause and effect relationship. For example, let's take a simple example. The scholar want to conduct a study, relationship between intelligence and size of shoe. Again I repeat, relationship between intelligence and size of shoe. And by chance, he concluded that there is a positive relationship between intelligence size of shoe. According to findings, we can say that those who want to become intelligent wear large shoes. It is illogical in nature. It means on the basis of cause and effect relationship, we cannot establish, on the basis of relationship studies, we cannot establish cause and effect relationship. For that, we have to conduct experiments. Now, the story starts. How to establish cause and effect relationship? I will discuss about the 4 statistical tools and 4 designs which are used to conduct the studies. How to establish cause and effect relationship. This is based on a concept and a principle. The question arises, what is the concept and what is the principle? See, there is our today's hypothetical title is Effect of Card on Intelligence. Scholar want to conduct a study on the title Effect of Card on Intelligence. Scholars' interest is to find out the effect of card on intelligence. Is it okay? In this hypothetical example, in this hypothetical title, the hypothetical title is in front of you, Effect of Card on Intelligence. There is an independent variable. Independent variable is known as a treatment. And what is treatment in our today's example? Card. Another is a dependent variable. In this hypothetical example, dependent variable is intelligence. It means here investigator interest is to find out the effect of independent variable on dependent variable. Effect of card on intelligence. That never happens. That never happens in a study. Simultaneously with independent variable, simultaneously with card, several other variables play a vital role in bringing the change in intelligence, in bringing the change in dependent variable. These may be change in intelligence is due to card plus, due to daily routine, food habits, lifestyle, heredity, and there is a long list of other variables also. But our interest is to find out the change in dependent variable only due to card, means independent variable. Our interest is not to find out the change in intelligence due to daily routine, due to food habits, due to lifestyle, heredity. Our purpose is only to find out the change only due to independent variable, that is card. Is it okay? Now, please try to understand the concept of 2 terminologies. Change in dependent variable means? Change in dependent variable means? In this hypothetical, intelligence. Please try to understand. Change in dependent variable means change in intelligence. Due to independent variable means due to please try to understand my point. Change in dependent variable means change in intelligence. Due to independent variable means due to card. Change in dependent variable due to independent variable means change in intelligence due to card is known as treatment variance. This is known as treatment variance. So treatment, again I repeat, treatment variance means change in dependent variable only due to independent variable. Is it okay? Change in dependent variable means change in intelligence other than independent variable means other than independent variable means other than card means daily routine, food habits, lifestyle, heredity. In our example, this is known as error variance. This is known as error variance. This is known as error variance. About which topic we are discussing? Establishment of cause and effect relationship. In this example, cause and effect relationship between card and intelligence. Is it okay? We should conduct a study in such a way that by following a principle, by following a concept of maximization of treatment variance and minimization of error variance, we have to conduct our study in such a way that we have to maximize the treatment variance and we have to minimize the error variance. Is it okay? Here, I didn't say that we have to eliminate the error variance. I have said Minimization of error variance. One point is clear from this, कि error variance cannot be eliminated. Only as a researcher we can try our level best to minimize the error variance. Is it okay? Now we will discuss about the process, how to maximize the treatment variance and how to minimize the error variance. We have to select a design, we have to select a statistical tool. By using that, we have to maximize the treatment variance and minimize the error variance. How to do this? We will discuss in detail. We will conduct the same study, that is effect of card on intelligence, by using 4 designs, by using 4 statistical tools, and in the end of the session you will decide which design is best and which technique is best. Is it okay? Now before that, we should have an idea about the variables, concept of variables. In this study, in this hypothetical example, how many variables we have? 2. One is independent, one is dependent. Independent is card, dependent is intelligence. Okay. What do you mean by variable? Let's define variable. We should have an idea about the variable also. Variable is a characteristic that has the tendency to change with respect to time, place, individual. Variable is a characteristic that has a tendency to change with respect to time, place, individual. Let's take example of intelligence. Intelligence is a variable. This has a tendency to change with respect to time. In the childhood, the intelligence was different. In adulthood, different. In old age, will be different. This changes with respect to time, with respect to place, with respect to individual also. You have different intelligence, I have different intelligence, she has different intelligence. Is it okay? Variable is a characteristic that has the tendency to change with respect to time, place, individual. There is a long list. Physiological variables, resting heart rate, resting respiratory rate. Management variables, sale. Sale is a variable. This has a tendency to differentiate with respect to time, place, individual. Achievement. Okay. Now we will discuss about the classification of variables. Classification of variables. Variables and their types. Without understanding the detailed concept of variables and their types, it will not be possible for us to conduct a genuine researches, valid researches, reliable researches. If I ask a question from you, gentlemen, can you classify this whole group? Classify? Classify? Male and female. Why you classified on the basis of gender? Only this classification is possible? No. Arts and science. It means different authors classified variables by taking different bases. On the basis of different bases, different types of classifications are there. So we should not be confused. In some books, you will find different classifications. In few books, you will find different types of classifications. I am going to discuss about only 2 types of classifications by taking 2 different bases. First one is on the basis of a causal model. Classification on the basis of a causal model. The classification of variables on the basis of a causal model. If on the basis of a causal model, if we classify all the variables, we classify into 3 categories. Only 3 types of variables are there. Where this causal model is applicable? This causal model is applicable to conduct experimental researches. This causal model is applicable to establish cause and effect relationship. This causal model is applicable to conduct clinical researches. In how many categories we divide? 3. One is independent variable. Our title is effect of card on intelligence. The independent variable is card. Next is dependent variable. In our hypothetical example, dependent variable is intelligence. And third category is confounding variable. Confounding variable. Our researcher, it's not of researcher's interest Our interest is to find out the effect of only independent variable on dependent variable. And these confounding variables are subdivided into two categories. One is intervening variable. One is intervening variable. Intervening variable means that is beyond the control of investigator. We cannot control. For example, climatic conditions. We cannot order Indradev, please stop rain. There will be any effect on the study due to rain will be considered as intervening variable, comes under the category of confounding variable. This will be considered as your limitations. Second one is extraneous variable. To a great extent we can control. To a great extent we can control. Examples are daily routine, we can control. Food habits, we can control. Social background, we cannot control. Social background will be considered as intervening variable. Heredity will be considered as intervening. We cannot change the heredity. Okay. Now we will discuss. We should have an idea about what is independent variable, what is dependent variable, what is confounding, and in the subcategory of confounding, what is intervening and what is extraneous variable. Let's discuss about one more classification on the basis of unit of measurement or on the basis of scaling techniques. On the basis of the unit of measurements and on the basis of the scaling techniques. On the basis of the unit of measurement and scaling techniques, we divide all the variables in 4 different categories. Only in 4 different categories. And these 4 different categories are, first one is a nominal scale. Nominal scale, this nominal scale is used in management researches, commerce researches very much. Nominal scale means when we collect data in a frequency or counts, in a whole number, in a discrete number. Suppose if I say number of males 23, number of females 24, you cannot say that number of males 24.2. That will be a discrete series, that will be a whole number. Is it okay? This nominal scale is subdivided into different categories. One is dichotomous. The word dicho means two. The word dicho means two. Tomius means having two ends. Example is smoking. Smoking is a variable, comes under the category of dichotomous of the nominal. Smoking divided into two categories, smokers and non-smokers. Gender, male, female, these are the dichotomous variable. Result, pass, fail, dichotomous variable. Is it okay? Next one is polytomous. Polytomous, divided in more than 2 categories. In dichotomous, in how many categories we divided? 2. Polytomous, divided among more than 2 categories. Maybe race, Indian, Japanese, Chinese, Germans. Is it okay? This polytomous is also subdivided into subcategories. One is nominal with order, we can arrange in order. Suppose, let us take an example. Achievement. Achievement is a variable or not? Yes. Variable is, it's very achievement. If we divide high, medium, low, we can arrange in order. Is it okay? Another is, we cannot arrange in order. Nominal without order. Race, Indian, German, Chinese, can we arrange in order? No one will be considered as superior, no will be considered as inferior. So this polytomous may be arranged in order and may not be arranged in order. Agree? Next one is the ordinal scale. Only we can measure in a order. Only we can measure in a order, maybe ascending order, maybe descending order. If I ask a question from scholar, do you exercise? Do you perform weight training? Yes or no? No. Who exercise regularly? It's a simple, my purpose is, there is no relationship of doing exercise or not doing exercise with this. My purpose is to explain the concept of ordinal scale. Suppose you do exercise regularly, and the jerk in your back takes place. Is it okay? And you are suffering from pain. Is it okay? Pain is a variable or not? This has a tendency to change with respect to time, place, individual, है ना? Okay. He approached doctor. Doctor asked him, what is the severity of pain? Accordingly, he will give the treatment. So he cannot say, I have 5 kg pain. He can express in order, sir, I have very high pain, I have medium pain, I have low pain. Suppose if I ask him, what is the beauty of your friend? So you cannot say that beauty is a variable. Beauty is a variable. He cannot say, ki my friend has a 5 centimeter beauty. He will express it, he or she has excellent beauty or above average beauty. It means beauty and this pain can be expressed in order, maybe ascending, maybe in descending. Is it okay? In management researches, in business researches, in economic researches, in social science researches, there is a long list of variables which can be measured only in ordinal scale. Is it okay? Next one is interval scale. Next one is interval scale. Interval scale means having same intervals in between but has no fixed zero. Having, again I repeat, having same intervals in between but has no fixed zero. Let's take an example of aggression. Example of aggression. Let's take example of aggression. Aggression is a variable. This girl and this girl, we measured the aggression of both, and she is having the score of 20 and she is having the score of 40. We can say that she is just double aggressive. Can we say? No, we cannot say. Aggression has no origin. Aggression has no fixed zero. But suppose she is in hypothetical example, she is having a 50 kg weight, she is having 100 kg weight. Suppose, so we can say that she is having double weight, since weight has a fixed zero. Is it okay? It means this interval scale there is no fixed zero. In ratio scale there is a fixed zero. Please try to recall my point. We have discussed about parametric statistics, and about how many parametric statistics we have discussed? 4. Independent t-test, dependent t-test 1, sample t-test 1-way ANOVA. All comes under the category of parametric statistics, and we have discussed that at least interval or ratio scale is required. It means in nominal scale and ordinal scale we cannot apply parametric statistics. We have to apply non-parametric statistics. Examples are in nominal scale. In management studies, you will see application of chi-square. Chi-square is non-parametric technique that is applied in nominal scale. In ordinal scale, you will apply Spearman method of correlation. Is it okay? But our purpose is not to discuss which technique is applied. Our purpose of today's lecture is how to establish cause and effect relationship. For that, which model is applicable? Causal model. We have independent variable, we have dependent variable, we have confounding variables, and our purpose is maximization of treatment variance and minimization of error variance. Again I repeat, please keep in your mind, our purpose is we have to maximize the treatment variance and we have to minimize the error variance. How? Let's discuss one by one. Now the story starts. By the use of appropriate design and by the use of statistical tools to establish cause and effect relationship. We have to select a design and we have to select a statistical technique to analyze data. It means, see the sentence, same experiment can be conducted by adopting different designs. Please try to understand my point. Same experiment can be conducted by you adopting different designs. And our today's title is Effect of Cardon Intelligence. Our today's title of our research is effect of card on intelligence. Is it okay? The objective is to find out the effect of card on intelligence. Is it okay? And the same study, same experiment, by same experiment I mean effect of card on intelligence can be conducted by using different designs, can be conducted by using different statistical techniques. Now I am going to discuss about the 4 designs and 4 techniques to conduct a single study, that is effect of card on intelligence. Let's start with the first. May be conducted by single group design, may be conducted by post test only random group design, may be conducted by repeated measure design, may be conducted by random group design. See, let's discuss one by one. We will start from single group design by taking a single. Already we have discussed about this, but again I am going to repeat this, and about second, third and fourth I will discuss in detail. About first we have discussed already during the discussion of effect of morning walk on blood pressure. There the title was effect of morning walk on blood pressure. Here the title is effect of card on intelligence. Concept is same. There was one independent variable and one dependent variable, that is morning walk on blood pressure. Here we have one independent variable, one dependent variable, card and intelligence. Is it okay? Now, or by adopting more designs, I am discussing about 4. Let's discuss by single group design. Our title is effect of card on intelligence. Independent variable is card, dependent variable is intelligence. See the structure. Please keep in the entirety of your mind about this structure, O1, X and O2. Please keep in your mind, in the language of research, O means observation. Capital O means observation. And X means always, X means treatment. Capital X means treatment. How many observations are there? This design explains that O1 means observation 1. Observation 1 means pretest. See, after collecting pretest data, you have to give X. X means treatment. That is card. For how many days? 1 month. And O2 means observation 2 means post test. It means here we compare pre and post. By using which technique? We have discussed. By using which technique? Paired t-test or dependent t-test or repeated measure t-test or correlated t-test. Is it okay? If the significant difference exists, we can say that yes, there is a significant effect of card on. Yani we established cause and effect relationship. Is it correct? We established. But what is the reliability and validity of this experiment? We have to follow the principle of maximization of treatment variance and minimization of error. We have to maximize the treatment variance and minimize the error variance. Suppose you all were the participants in this study and regularly treatment is given to you, that is card is given to you, but your mother provided you vitamin tablets also simultaneously with the card. There may be chances of instead of the effect of this treatment, maybe the effect of that vitamins. It means this principle is not fulfilled. Is it okay? It means this design is an ill design. This design doesn't fulfill the principle of maximization of treatment variance and minimization of error. If we conduct our study by using this design and by using dependent t-test, may be possible our papers will not be published in the refereed journals, indexed in Scopus, indexed in Web of Science, indexed in PubMed. Okay. Our title is Effect of Card on Intelligence, and we conducted this study by using which design? We conducted this study by using which design? Beta, by using single group design. By using single group design. And by using which technique? Paired t-test. Okay. Yani same technique, that is effect of card on intelligence. We conducted the study by using single group design and by applying the statistical tool that is known as dependent t-test or paired t-test. Is it okay? But we concluded that this technique doesn't fulfill the principle of maximization of treatment variance and minimization of variance. Same study, see the row scores of the same. How many the study was conducted on? 20 subjects. First you have taken pre, then in between this treatment was given, post. Is it okay? Now same study can be conducted by using repeated measure design. Same study can be conducted by using repeated measure design. Repeated measure design. How many observations were there in single group design? 2, pre and post. See the structure of this design. O1, X1, O2, X2, O3. O means observation. X means treatment. Only one treatment is there in our example. That is card. Is it okay? O1 means pre-test was taken. And let's take an example. In the single group design, for how many days you have given the card? For 1 month. May be possible. In the first 15 days, intelligence was improved. But due to overdose of the card, that decreases also. We require exact date of improvement. Where to 10 days is sufficient. Instead of effect of drug on this intelligence, we can say that effect of drug X on Y disease. If you give medicine for 1 month, that may be overdose also. Maybe 3 days medicine may be possible. Is it okay? So instead of 2 observations and instead of fixing the 1 month duration, we divide the entire treatment period in the different intervals. O1 means pre-test, X1 is treatment for 1 week, O2 means mid-test, X continues for 1 more week, O3 means final test, post-test. Here how many observations are there? 3. Pre, mid and post. Is it okay? But you may take more than 3 also. Pre, mid 1, mid 2, mid 3. I have taken only 3. That doesn't mean that in repeated measure design, you may divide the entire duration of the treatment into different subparts. And we take more than 2 observations, maybe 3 and maybe of n numbers. And in this hypothetical example, how many observations we are taking? Only 3. Is it okay? So, in this, our purpose was, please, this technique, this design is used in economics and management researches. See, our title is Effect of Card on. By the help of this design, this objective is fulfilled. We can find out the effect of card on intelligence. Simultaneously, we can find out the trend of the effect of card. Where increases, where decreases. And there is a tradition of calculating the trend in commerce and management researches, in market researches. You can apply in survey studies. What is the trend? Yes. You can find out the variations, ups and downs. Is it okay? This design is better than single group design. Which technique will be used in this? In this, the technique which will be used is known as repeated measure ANOVA. I will show you. I will show you how to calculate. Is it okay? In this repeated measure ANOVA, same study, effect of card on intelligence, we conducted by using 2 different designs, by using single group design and by using repeated measure design. Is it okay? Clear? Next, see the structure. See, row scores are there. Number of subjects is 20. The study was conducted on the same number of subjects, 20. But instead of 2, you have taken the pre-test, mid-test and post-test, and you compared by using which technique? Repeated measure ANOVA, repeated measure analysis of variance. Is it okay? Now, same study can be conducted by using post-test only random group design. Same study can be conducted by using post-test only random group design. How to conduct? See the structure. How many groups were there in single group design? How many groups were there in single group design? How many groups were there in single group design? Gentlemen, there was a single group, one group. We have collected data twice in the form of a pre and post. There was only single group. There is no need to discuss about this. How many groups were there in repeated measure design? Single group design. We have to collect data more than 2 times, but instead of one group in this design, there are 2 groups. One is experimental, one is control. One is experimental, one is control. And they see post-test only random group design. There is no need to take pre-test. We believe that initially both the groups are equal. We believe that initially both the groups are equal. Treatment is given to one, not to another. And finally, after treatment, post-test was taken for control and post-test was taken for experimental group. And we have to compare post-test of both. Is it okay? Clear? If the difference exists, we can say that is due to CARD, that is due to independent variable. So which technique will be used in this? How many observations are there? 2. Post of experimental and post of control. Groups are independent. We have discussed about this technique. We have to use independent t-test. We are using separate groups. Same as we have discussed male and female. Here, experimental control, independence is there. But in single group design, we were having the 2 different observations of the same group. So we use the technique dependent t-test. And in this we are using independent t-test. Why? Since groups are independent in nature. Is it okay? But we believed that initial level of both the group is equal. Maybe possibility initially both the groups are not equal. So this may have error also. This is not a perfect design. This works on our belief only. We are sure initially both the groups are equal, but by chance may be difference between the groups. Is it okay? So we have discussed about the conduct of the same title, conduct of the same study, that is effect of CARD on intelligence by using how many designs? 3. Single group design, repeated measure design, post-test only random group design. Is it okay? But we also conclude that we are not satisfied with these designs. You can publish these articles in the medium level of journals, but if you want to publish your articles in the top journals, we have to conduct our study in a controlled condition. How to conduct? Now the main story now starts. That is Ross course. See the Ross course. On how many subjects this was conducted? No, on 40 subjects. Serial number is this: 40 experimental, 20 experimental and 20? This is the difference. Is it okay? Now see this, which design is best? Which design is best? But till now, we didn't discuss about the best design. We have discussed about only 3 designs: single group design, repeated measure design, post-test only random group design. Now, we have to decide on the basis of a law, on the basis of a principle. Let's discuss about this principle. We we'll discuss about early experimentation. By early experimentation, I mean the history of experiments, early experiments. Early experimentation means I will discuss about the earlier assumptions of experimental research. What were the earlier assumptions? This law was given in the year 1872 by a researcher that is known as the law of a single variable. This is known as the law of a single variable. And the concept was given by John Stuart Mill. The concept was given by John Stuart Mill. Is it okay? It means we have to conduct our study by following the law of single variable. What does it mean? It is very important to understand about the concept of a law of single variables. Please try to understand. In the words of John Stuart Mill, please. This law of single variable says that if two situations are alike in all respect, if one element is added to one, not to another, or if one element is subtracted from one, not from another, if the difference exists, that is due to added element or subtracted element. Please try to understand it. Let's discuss again with hypothetical example. If two situations are alike in all respect, it means suppose by two situations, I mean we have two groups. One is experimental and one is control. If both are alike in all respect, if both are equal in all respect, is it okay? If two situations are alike in all respect, two situations means experimental and control. Is it okay? If one element is added to one, not to, if added means if one element is given to one, not to another, what we are giving? Card. If card is given to one, not to another, or if one element is subtracted from one, not from another, but we are not subtracting anything. This second sentence is not applicable in our example. We are only adding, that is card. We are not subtracting anything. Is it okay? If the difference exists between control and experimental, this difference is due to added element or subtracted element. Added element is applicable here, subtracted element is not applicable here. Is it okay? So, due to this law of single variable, there is a concept of a control group. There is a concept of control group, and the best suitable design is random group design. Random group design. The best suitable design is random group design. See, random group design. We should not be confused. This random group design in few literature, this is you may see by the name pre-test post-test control group design. Another name of random group design is pre-test post-test control group design. You will see in different articles in clinical researches कि the pre-test post-test control group design was used. See the structure. Now try to understand how many groups are there. Two. One is experimental and the other is control. O1 means pre-test of experimental. O3 means pre-test of control. X means treatment. Treatment is card. And C is nothing. Nothing is given to. O2 means post-test of experimental. O4 means post-test of control. Now I am repeating the law of a single variable. If two situations are alike in all respect, if experimental and control group are equal in all respect, if one element is added to one, it means X is added to experimental group. X means card is given to experimental group. If the difference exists between these two, between O2 and O4, this difference is due to added element, that is X, that is card. Is it okay? Now my important question is, How many pre-tests are there? 2. Which one? O1 and O3. There will be difference between these or not? Wait. She said there will be difference. No. We assume as per law, if both groups are alike in all respect, there should not be any difference. Suppose there is a competition between him and me of 100-meter race. I am experimental group and he is control group. We have to stand on starting line. Suppose he stand 10 meters away in the starting line, and if he wins, we can say that he will. No. Initially both the groups should be same. Is it okay? Otherwise, but you tried, please try to understand my point. We tried our level best to select all subjects randomly, and we divide all groups randomly without any biasness. The groups will be equal. We tried our level best, but significant difference exists between O1 and O3. It means pre-test of both. What does it mean? What does it mean? O1 and O3 are not equal. What does it mean? It means कि the biasness exists. We try our level best, but unintentionally we created a biasness. Is it okay? Okay. This will affect our study. This will affect our study. Yes. This will affect this differential assignment. The difference between the two pre-tests, that is O1, O3, will affect our study in a negative way or in a positive way. Why it can affect in both the ways? How it can affect in both the ways? This will affect in a negative way only. There will be no positive effect. There will be only negative effects. Is it okay? Agree? Then what you will do? One option is divide the subjects again, try to equalize the subjects, but we have parallel option. By applying ANCOVA, analysis of covariance, we can rectify the results. ANCOVA, 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 analysis of covariance. By using analysis of covariance. By using analysis of covariance. How many pretests are there? 2, O1, O3. Both the groups should be equal. But there is a word in analysis of covariance. Co means together. If both experimental and control covariates, if the difference exists, covariates, that will affect the study in a negative way. We have discussed about this. ANCOVA, analysis of covariance, is a statistical technique. By applying that, by eliminating the effect of covariate, means by eliminating the effect of unequal assignment, we can find out the actual effect of a treatment. Is it okay? This will be rectified by ANCOVA, analysis of covariance. It means to conduct a research on the title effect of curd on intelligence. Out of these 4 designs, single group design, repeated measure design, post test only random group design, this random group design is considered as the best, since this has the concept of covariate, and we eliminate the effect of covariate. We cannot say that we eliminate. We do not eliminate. We adjust the error of covariate. Is it okay? Clear? And again I repeat, if we conduct our study by using single group design, we have to use the technique dependent t-test. In case of repeated measure design, we have to apply the technique repeated measure ANOVA, not ANOVA, repeated measure ANOVA. If we conduct the study by using a post-test only random group design, we have to use independent t-test, and if we use this technique, this design, random group design, we have to use ANCOVA. So out of 4 design, random group design is best, and out of 4 statistical tools, which technique is full of statistical control? ANCOVA. But we compared only 4 designs and 4 techniques, but we can select, we can opt better design than this also. That is Solomon 4 group design, single blind experiments, double blind experiments, double blind crossover trials. But this design is also a satisfactory design. Why? The principle of maximization of treatment variance and minimization of error variance is fulfilled by using this design. And by using which technique? ANCOVA, analysis of covariance. Is it okay? Now we will discuss about the analysis of these 4 techniques. We have row scores. I am going to copy these row scores. I will put on SPSS spreadsheet. About one, that is one single group design in which we are having pre and post, we have discussed, but again I will repeat first also. Now let's start. From where we have to start? From where we have to start? Single group design. These are the scores, please. These are the scores. I am copying these scores. See, I copied these scores. Is it okay? Now I am going to paste these scores in SPSS. I am going to paste these scores in SPSS. In which view? Data view. It means directly we cannot paste. First we have to paste in this Word, and we will copy from Word. No problem. I am pasting these scores here, and from here I am copying these scores again, and I am going to I copied, and I am going to paste in this data view. In how many columns I pasted? 2 columns. First column is for pre, second column is for post. Already we have discussed about that. Please try to recall the command and tell me. Okay, I analyzed, I clicked on analyze. Compare means paired sample t-test, good. Make a pair, pre, post, click on OK. Is it okay? What is the t-value? 1.36. Is it significant? No, there is no significant difference. It means no significant difference of card is found on intent. Is it okay? We have discussed this by using which design? Single group design. Okay. Now without saving, I am copying, and we will proceed to the next part. That is which one? Repeat. How many observations we are having in this? It means 3 observations. It means we have to take 3. Huh? It is compulsory to take 3. No, this will be of n numbers. In this example, I am taking 3. Maybe pre, mid 1, mid 2. The observations will be more than 2. But we are taking only 3. Pre, mid, fine. Which statistical technique will be used? Repeated measure ANOVA. Please try to understand. Repeated measure ANOVA. I am copying these scores. See, I am copying these scores. After copying these scores, first I will paste in Word. After pasting Word, again I am copying these scores, and I am copying these scores in SPSS in data view, and directly I pasted. The first column is for pre, second is for mid, third one is for post. Go to variable view. This is pre, this is mid, this is final or post. Is it okay? Data entry is complete. Which technique we are going to use? Repeated measure ANOVA. See, go to analyze, go to, please try to understand, go to journal linear model. Go to journal linear model. Go to journal linear model. Is it okay? Now go to repeated measures. Click on this repeated measures. Now see, what do you mean by factor? See, the factor is written. Factor means we have three factors, three observations. So you may write any terminology, but we are using the terminology observations, tests. Instead of factor, we can write down the tests, pre-test, post. So either write test or observation. Tell me. Test is appropriate or observation? Observation. How many observations we have? Three. Observation. Number of, how many levels are there for observation? 3. Write down the 3. You may write down 4, 5, 6, but we are having 3. So I have written 3. Add. Is it okay? How many observations we added? 3. Now click on define. What is your first observation? Bring pre in front of first, mid in front of second, post in front of. Is it okay? Clear? But please keep in your mind, this SPSS has the facility of graphical representation also. We didn't give the command for graph. In this I am giving the command for graph also. Plots. I am bringing this observation in the horizontal axis. Simultaneously, I am giving the command of graph also. Click OK. Our purpose, see, please see this cursor arrow. How many observations are there? Pre, mid, post, agree? What is our objective? To find out the significant difference between the pre, mid and post in relation to intelligence. Is it okay? Now see, see, where is my cursor? Observation. It means we are comparing observations. How many observations? 3. To see the F value. Is it significant? No significant. It means there is no effect of card on intelligence. Is it okay? But if insignificant difference between pre, mid and final exists, it means the study ends, and we will conclude there is no significant effect of independent variable on dependent variable. But if the significant difference exists, may be possible the significant effect of significant increase or decrease may be possible in between pre and mid, may not be possible in between mid and final. Is it okay? If the significant difference exists, in that case we have to see the trend. We have to see the trend. Same as one-way ANOVA. In one-way ANOVA, we applied post hoc test to compare paired means. So here we have to see the trend. How many trends are there? Change. Please try to understand the specific terminologies. Change from first means pre to mid is known as linear trend. Linear trend is a fixed terminology used to identify the change between first and second. That is known as linear trend. From second to third, quadratic trend. From third to fourth, cubic trend. only there are three specific terminologies. Please try to understand, only there are three specific terminologies: linear, quadratic, cubic. After that, fourth order, fifth order, sixth order, and so on. But how many trends are there? Only. Why three, beta? Why three? How many trends are there? How many observations are there? Three. Observation 1, 2, 3. How many trends are there? In three observations, only two trends are possible. From first to second and second to third. Three trends are possible only in case of four observations. It means we have to calculate linear trend and quadratic trend. Already these are, see this linear trend, this linear trend, this is quadratic trend. Since their overall trend is not found significant, the linear trend is also insignificant and quadratic trend is also insignificant. Agree? Clear? And you may see the graph. You see, this is an increase, but this is not a significant increase. This is not a significant difference. It seems there is a difference between these three, but no significant difference exists between pre, mid, and post. Is it okay? Clear? About how many techniques we have discussed? Two techniques. We have discussed about only two techniques. And about how many designs we have discussed till now? Two. With respect to the application, practical application, only two. That is single group design by using which technique? Dependency test. And repeated measure design by using which technique? Repeated measure ANOVA. Proceed to the third. Already we have done. That is independent test, but we will repeat this once again. And see which technique? Independent. How many groups are there? Two groups. See this. See raw scores. Is it okay? Both the groups are independent in nature. Post of pre and post of experimental and post of control. Paste these score here. And I am copying these scores. No, it means I didn't copy properly. Now I am going to copy all scores. Already we have studied about this. In how many columns we have to enter all the scores? In a single column. Good. In a single column. I am going to paste these scores. Again I am cutting all these scores and pasting after these. First 20 scores belongs to, I am giving the value. 1 stands for experimental and 2 stands for control group. Sorry. 18. कॉपी 18 हुआ होगा. ठीक है, 18 तक करते. ठीक है. Our purpose is to learn this up to 18. Okay, 18. Is it okay? This is 2. Sorry. Is it okay? Now I am deleting all these scores. Is it okay? In the first column, intelligence. Why test intelligence of all experimental group or control group? This is the intelligence scores of both the groups. Why tests? In the second column, we have groups. How many groups we have? 2. In front of the group, go to values. 1 means experimental group. Add. 2 means control group. Add. Click on OK. Data entry is complete. Is it okay? Already we have done this. Now tell me the commands. You have to tell. Okay. Analyze. Compare means independent sample t-test. Yes. Bring intelligence in the test variable. Group in the grouping variable. Group A 1 and group 2 2. Continue. Okay. C. What is the t value? 0.7. Significance 0.47. Higher than the 0.05. There is no significant difference between experimental and control. There is no significant effect of card on intelligence. Is it okay? About how many designs we have discussed practically? 3. Which one? Single group design, repeated measure design, post test only random group design. And about how many techniques we have discussed? 3. Dependent t-test, repeated measure ANOVA, independent t-test. Now the main part remains how to analyze by using random group design and by applying which technique? ANCOVA. I will proceed. See the data, see the raw scores, on how many subjects the study was conducted? Sir, on 40 subjects. Please try to understand my point. On serial number is 20 for experimental and 20 for control. On how many subjects the study was conducted? 40. Is it okay? Consisting of equal sample size, 20 in experimental group and 20 in control group. But this technique may be applied in equal as well as in unequal sample size. Is it okay? Is it okay? Clear. How many observations are there? 4 observations. Pre of experimental, pre of control, post of experimental, post of control. In how many columns we have to enter data? We should have an idea about that. I am copying these scores, all the scores, 20 scores. I copied these scores and I am going to paste here, and here I am copying these scores and I am going to copy in SPSS. Please tell me, please try to understand. This first column is for pre-test of experimental. Second column is for post-test of experimental. Next one is pre of control. Fourth one is post of control. Dear scholars, we have to enter all the pre-test scores in the single column, all the post-test scores in the single column. I am cutting this pre-test scores and I am going to paste the pre-test scores after the pre-test score of experimental group. Is it okay? Yes. I am cutting these post-test scores also. It means we have to enter all the data in only 2 columns. First column for pre, second column for post. How many pre-test scores are there? 40. First 20 for experimental, next 20 for control. And how many post-test scores are there? 40. First 20 for first 20 for experimental and next 20 for control. Okay, please write down, this is pre and this is it okay? Now again go to data view, but we have to give the command in both the columns. See, in both the columns, first 20 scores belong to experimental. It means one stands for experimental and 2 stands for control. Is it okay? Go to variable view. This column is for groups and go to values and one stands for experimental group. Experimental group, add, and 2 stands for add. Click on OK. The data entry is complete. Again I repeat, we are discussing about ANCOVA. We have to use only 3 columns. Again I repeat, in first column we have to enter all the scores for pre-test of both groups, experimental, control. In the second group we have to enter all the scores belongs to post-test of experimental, control, and in the third we have to give value for a label, that is 1 stands for experimental and 2 stands for control in our hypothetical example. Okay. Now the commands, go to analyze, go to general linear model and go to univariate. See, go to univariate and bring this. Which column is considered as a covariate? We have discussed earlier. Covariate means initially both the groups should be equal, but there is a covariation is there. Which column is covariate? Pre is a covariate. We are eliminating the effect of the covariate. So bring this pre in. Bring this pre in covariate. Post independent, group in a fixed factor. That's all. Again I repeat, bring pre in the covariate, post in the dependent, and groups in the fixed factor. Click on OK, or simultaneously you can descriptive statistics. You may calculate descriptive statistics also. Continue. OK. Please try to understand my point. Please see the screen. Where is my cursor? Groups, how many we have? In experimental groups, how many subjects we have? 20. In control group, how many subjects we have? 20. It means data entry is complete. Correct. We entered all the scores correctly. Experimental group mean is 10.75. Control group mean is 10.25. We are comparing groups. See, we are comparing groups. After adjusting the effect of covariate, after adjusting the error of covariate. So see the groups see the value in front of groups. See, this is a group. See, we are comparing only group. We are not comparing pre. We are comparing only groups. See the value in front of group. What is the value? 0.31. This is the significance value is 0.579. It's highly insignificant. It's higher than 0.05. There is no significant effect of taking card on intelligence. We have discussed in detail about the random group design. Another name of random group design is pre-test, post-test control group design. And if we use random group design, which statistical tool is used? ANCOVA, analysis of covariance. And see, in this we are comparing groups. Which measure of a group? My last point. Which measure of a group? In independent t-test, we compare please try to understand. Independent t-test, we compare the means of pre and post. In repeated measure ANOVA, we compared the mean of pre, mid and post. In post test only random group design, we compare the mean of experimental and control. Here we are comparing some measure. Please try to understand. We are comparing a measure after the adjustment of the covariate. It means neither we are comparing pre-test mean nor we are comparing post-test means. We are comparing adjusted means. The term which is used here is adjusted mean after the adjustment of covariate. Good. After the adjustment of covariate. And where is adjusted mean? Where is adjusted mean? See how you will identify the adjusted mean. The adjusted mean is given by this value. See adjusted. Wait. Adjusted mean. It's not given in this adjusted means. So how to get the adjusted means? I will give the command again for adjusted means. I am without saving. Go to analyze. Go to general linear model. Univariate. Go to options and compare this groups and compare mean effects and continue. You will find the value C adjusted means. Where is C? This is denoted by a small a. See, this is mentioned by, see my cursor, this is mentioned by the small a. The adjusted mean of experimental group is 10.642 and adjusted means of control group is 10.358. It means here in this we compare the adjusted means to find out the effect of card on intelligence. We conducted the same study by using 4 designs: single group design, repeated measure design, post test only random group design, and random group design. Another name is pre-test post-test control group design. And in the second session today, we have discussed about the application of 4 statistical tools: dependent t-test, repeated measure ANOVA, independent t-test, and analysis of covariance. So I tried my level best to cover some important aspects